All right, students, this is Unit 7, Circles, Lesson 7.6, Circles, Circumference, and Area. You're right here. Make sure you get a date, time, location, and guardian's signature, a parent or guardian signature. Let's do a quick review here. I'm going to read this and see if you can't draw it. The diameter of a circle is 60 inches long, and the chord of the circle is 48 inches long. The diameter bisects the chord. How far is the chord from the center of the circle? Okay, so first it says we have a diameter. So let's start with something. We have a diameter and it is 60 inches long. So diameter implies there's a center. You're going to trace that diameter, 60 inches, which means you can do this. This is 30 inches and 30 inches. We have a chord that is 48 inches long. 48 inches long, a chord. So that is 48 inches long. The diameter bisects the chord. So that means we should have drawn this. So I'm going to swing it around this way. We're going to get the same idea here. So that's, again, 30. It's asking how far is the chord from the center of the circle. So what's being asked is this segment here. Stops right there and it's at the center, which implies you have a right angle and this is being cut in half. Our goal is to find that pink. Let's make an X here. And we can split that 48, so that's going to be 12 and 12. Now, if you don't see a right triangle, remember you can always move or draw in a radius. Right now you don't see a right triangle, but you do have a right angle. So you want to try to draw in another radius, and the reason why I can draw that in is because all radii are equal. And since all radii are equal, this is also 30. Our goal is to find the pink there. Okay, follow along. You do your own math. Start factoring. All right, now you see what you can pull out. And we can pull out a pair of 2s. Whoops. We can break this down as well. And a 3, that's going to be 21. So that's 2 times 3. That's going to be 6 square root of 21. That's our value of x, or 756 square root 27.5 approximately. You should be able to do both. All right, now today we're going to talk about circumference and area. Circumference and area. By the time you're done, you're going to know circle, radius, diameter, circumference, area, and then the word pi, which is this Greek letter right there. You are going to need a scientific calculator today. First, let's talk about what the definition of pi is, the basic definition. It says, trace the circumference of the circle and then trace the diameter. So for each of these, you're going to trace the circumference. And then go back and trace the diameter. So in all of these circles, the circumferences are different sizes. You have a medium, you have large, and you have small. And the diameters are different sizes. Again, you have medium, you have large, you have small. So, but all the circles are the same shape. Obviously, they're circles. They're just different sizes. Same shape, different size. Same shape, different size. That means they are similar. And let's recap what similar means. Similarity means that we're going to end up with congruent angles and ratios which are equal. They're the same shape, different size. That means we are going to have similarity means congruent angles, ratios equal. Ratios equal is what's key here, because there's a very particular ratio we're going to take a look at right here. This very special ratio, we're going to divide the circumference by the diameter. And since all circles are similar, this ratio will be the same for all circles, regardless of their shapes, because that ratio is going to be equal because they are similar. So let's take a look and see what ratio is actually being used here. So the ratio we're looking at is specifically the circumference divided by the diameter. That's going to give us a very particular ratio, and it has a special name. In all circles, the circumference divided by the diameter is going to equal the ratio pi. So let's take a look here. And pi, you guys know as 3.14159, etc. You're going to have to be familiar with pi up until about the 4th digit there. So let's take a look and see what we can do with this ratio. We just figured out the circumference divided by the diameter is going to equal pi. Now, our goal is we're going to isolate that circumference. So we're going to times both sides by diameter. So you just now figured out that circumference equals the diameter times pi. You guys are probably familiar with this since the diameter is made up of 2 radii. You might have memorized this in the past, 2 pi r, that diameter being the 2 radii, but realize I am never going to use that one. And the reason is because it gets mixed up with area of a circle, which is pi times that radius squared. And I want you to put parentheses around radius squared, please. So these are your 2 main equations that you need to be familiar with. Circumference equals diameter times pi. Area equals pi radius squared. Let's write those 2 equations out here. Circumference equals diameter times pi. Let me keep my color scheme straight here. Circumference equals diameter times pi. And area equals pi, parentheses, times the radius squared. That's how you find the area and circumference of a circle. Write those down. Now we got this handy dandy little jingle here, and I'm going to give credit where credit is due. This is partially due to the inspiration of alumni, Courtney, Lauren, and Megan, 2007. So there was an inspiration there. I captured their inspiration and codified this song. Ready? I want you to write this under C. I'd like you to write the letter C, D, pi. I, C, D, pi. Now this one, write apple. Pi is really, really good. Write those down. Put your pencils down. Get ready to sing. Goes like this. C, D, pi. I, C, D, pi. C, D, pi. I, C, D, pi. Apple pie is really, really good. Apple pie is really, really good. Ready? And sing with me. C, D, pi. I, C, D, pi. C, D, pi. I, C, D, pi. Apple pie is really, really good. Apple pie is really, really good. Now drive your parents crazy and sing with me this time. Ready? And C, D, pi. I, C, D, pi. C, D, pi. I, C, D, pi. Apple pie is really, really good. Apple pie is really, really good. The most annoying part of this song is it absolutely positively has no end. But let me reiterate what this means. C, D pi, that circumference equals D pi. Apple pie is really, really good. That's where we get the R squared from. That way you will never, ever mix these 2 equations up if you take the time to memorize the jingle. Let's put this to work. First, I need to introduce you to your pi key on your calculators. On your calculators, for the TI 30XA, you actually have a pi key. It's right there on the left-hand side. See if you can't find it. When you push that pi key, you're going to get a full decimal It's 3.1419159, etc. For those of you using the TI 83 or 84, for those of you who have a TI 83, you first have to hit the shift key, and then pi is right above there. So you hit shift, then pi, and again, when you do that, you're going to see the 3.14159, etc. That's called the pi key. Now, if you don't have a pi key, you should. If you have a scientific calculator, you can just use in your calculation 3.1416 is fine. I'll let you use that. But the most accurate way to do this is what's called pi form. I'm going to show you both ways. You're going to learn to express your answers with pi and without pi. In other words, you leave the symbol in the answer. Without pi, it's decimal form. Let me show you for both. We're going to do circumference, and then we're going to do area. Number one, our diameter is 10, which means our radius is 5, which means our r squared is going to be 25. Let's take a look here. Let's do all three of these while we're at it here. Our diameter is 16. Our radius is 8. Our r squared is 8 times 8 is 64. Our diameter here is 6, which means our radius is 3. Our radius squared is 3 times 3, that's 9. Now for each of these circles, we're going to find circumference, and then we're going to find area. Circumference and area. We're going to find it in both forms. The first form, right here by circumference, I'd like you to write the equation. It goes C d pi I c d pi. C d pi I c d pi. Next one. Apple pie is really, really good. Apple pie is really, really good. So here, our diameter in pi form is going to be, our diameter is 10. So circumference for this first circle, we wanted to find circumference, it's simply 10 pi, and my units are meters. Circumference is one dimension, therefore we only do meters. That's it, you're done. That's actually the circumference, 10 pi. Really? You don't believe me? Let's do the next one. Again, it's C equals diameter times pi. Our diameter here is 16, so it's going to be 16 pi meters. Ta-da! You're done. That's actually the preferred version. That's called with pi form. This one, again, C equals d pi. Our d is 6, so it's 6 pi meters. For area, we're doing pi r squared, and we already have r squared for this one. It's 5 times 5, so our area is going to be 25 pi meters squared. Area is 2 dimensions, so it's meters squared. This one, I already have my r squared, so that's going to be 64 pi meters squared. This one, I already have my r squared, so that's going to be 9 pi meters squared. This is called pi form. It's actually the most accurate version. It's what's most commonly used also in trig and calculus. Now, the decimal form, you get an approximation of all of these. This is where you can use the pi key on your calculator. We're going to go pi times 10. So you hit the pi key, times by 10, and you round to the second decimal, which in this case is 31.42. And that's meters. This one, you hit the pi key first, and we're going to times by 16. Round to the second decimal, that's 50.27 meters. Next one, you hit the pi key, times by 6 this time. That's 18.85. Meters. Remember, circumference is only one dimension. It's just length, so it's not meters squared. For area, it's 25 pi in this case, so you're going to hit the pi key times 25. .54, second decimal place, approximately 78.54 meters squared. This one, you hit 64 and hit the pi key. Please do this with me so you know how to use your calculator. Times 64. That's 201.06 meters squared. Next one, we hit the pi key, times by 9. All right, so this is what's called pi form on the left and the decimal form on the right, with pi on the left, without pi on the right. In all honesty, this is the preferred version unless you're doing something else with it. Let's do two examples together. It says here, if a wheel is 24 inches in diameter, how many revolutions will it take to travel 100 feet? Be really careful with this. Students' first instincts is to do this. They just do 100 divided by 24. That is so wrong on so many levels. So be really careful about making hasty, snap decisions and pay close attention to detail. For example, some of the detail I want you to notice here is if a wheel is 24 inches in diameter, how many revolutions will it take to travel 100 feet? You have to watch your units. So let's kind of draw what we have going on here. We have a wheel, which is 24 inches in diameter. So that whole thing is 24 inches. And we have something that deals with 100 feet. So we have a length of 100 feet. Here's a basic rule of thumb. Convert before you crunch. That means convert your units to the same unit before you crunch your numbers. Convert your units before you crunch your numbers. It's going to be really, really important. So either you take feet into inches or you take inches into feet. It really doesn't matter which way you go. I tend to take the larger and make it smaller. So I'm going to change 100 feet into inches by going 100 times 12. You get 1,200 inches. Now, your units are the same. Now watch it. You're not simply now going to do 1,200 divided by 24. Again, that is so wrong on so many levels because you need to read very carefully. If a wheel is 24 inches diameter, how many revolutions. This wheel here, when we talk about a revolution, we're talking about the wheel turning, right? Can you trace that wheel there? Trace it again. Trace it again. What does that feel like in the circle? When you say the word revolution and you go like that, ask yourself, what part of the circle is that? You should recognize that revolution is the same as circumference. And I'm asking how many revolutions? I'm asking how many circumferences? So I write my equation for circumference, C d pi. I see d pi. I'm going to calculate it. Diameter is 24. Times that by the pi. Now I can leave it at 24 pi inches, but the problem is I have to do something with that. So I need to get it in its decimal form. I'm going to pause and let you catch up. I go 24 times the pi key on the calculator. And I get 75.398, so I'm going to write that 79.40. Now that is one circumference, which this is same as one revolution. I'm being asked how many revolutions does it take to go 100 feet? 100 feet is 1,200 inches. I'm going to divide by my one revolution, which is 79.40 inches. Notice my units are the same. Ready here? So we do 1,200 divided by 79.40, and we get 15.1. So it is approximately 15 revolutions. Now, I want you to take this page, since I've done it for you and with you, your job is to this. I'd like you to write 1, 2, 3, 4 bullets there. Your job is to write what were the 4 main steps to this problem? I'm going to set the timer for 1 minute. Your job is to go back and write what are the 4 main steps to solving this problem. You have a minute to summarize. Start summarizing. Go. Your job is to summarize. What are the 4 steps to doing this problem? All righty. Let's take a shot at one more problem here. It says the area of a circle is 200 pi meters squared. What is the circumference of the circle? So we ask ourselves first what information we have. We have the area. So I'm just going to write area equals 200 pi meters squared. We want the circumference. So down here, you just write circumference equals d pi. Let's see what we can do here. Don't know what to do, you always do what you can do. And I don't know, for all I need is my diameter. The problem is I'm not given my diameter. It's not handed to me in a silver platter, so you ask yourself, what do you know? Well, I know the area equation, don't I? Right? I at least know that. Ah, looky there, that's the same. So I can go like this. 200 pi equals pi r squared. Let's solve for the radius here. Divide by pi. So I have 200 equals r squared. Backtrack a square, you square root. That's not perfect, so I'm going to go ahead and factor it. That's going to be 2 and 100, 2 and 50, 2 and quarters. So I find here, I take my dates out, got a pair of 2s and a pair of 5. So that's going to be 10 square root of 2. Now ask yourself, before you get all hasty, what is it that you just found? You just found the radius. So take a moment and just draw that. That radius is 10 root 2. But I need the diameter. My diameter is just 2 radii. So you walk it across here. That, my friends, is your diameter. So 10 root 2 plus 10 root 2 is 20 root 2 pi. Lo and behold, there's your circumference. Let's take a look here what the units were. Our units were meters. So we're going to come down here, and our final answer is 20 root 2 pi meters. Let's go back to your reference booklet. Find this page in your reference booklet. This is where you're at. You're in circles, so there's your angles and circles. Undercover right angles, your right triangle toolbox. Tan, if bisect, then perpendicular, and we're right here. Just write your equations out. C equals d pi, area equals pi r squared. Keep your parentheses there. And remember, the song goes like this. C, d pi, I see d pi. C, d pi, I see d pi. Apple pie is really, really good. Apple pie is really, really good. Go ahead and bug the daylights out of your family with C, d pi, I see d pi. Apple pie is really, really good. Apple pie is really, really good. God bless you guys. See you in class.